Well, hello, fifth grade. Welcome to Thursday, L79 Dividing Fractions. Hope you're well. Please make sure to take good notes. We're going to first look at something from a visual perspective, but then we're going to swiftly move to, well, how do we really do the math? So today we're going to be looking at dividing fractions, and I want to first look at this problem, 3/4 divided by 1/8. Now, I don't think we have enough tools right now to be able to handle this, so we're going to look at something visually so we can prove it later on. And so let's say I was going to draw a circle. I'm going to break that up into fourths, and I'm going to shade 3/4 of that. Makes sense, right? Now they want me to divide that into 1/8. So what I'm going to do is I'm going to break the circle up into eighths by a nice little line like that, a line like that, and another line, and another line. Now you can see that I've broken the whole circle up into eighths, 8 equal parts. Now, because I've divided it by eighths, what I'm thinking about is, well, how many eighths exist in that 3/4? And we could name this is an eighth, there's 2, there's 3, there's 4, there's 5, and there's 6. Therefore, 3/4 divided by 1/8 is simply 6. You may go, oh, well, that wasn't so bad. Well, no, it's not bad, but as I say often, if we had to visually draw out everything, our pictures wouldn't always work. Because I mean, right now there's 3/4 and 1/8. We can draw those. However, what if I give you like 5/17 divided by 9/32? Our ability to break that down into picture form won't work well. So this is where I want to swiftly move into, well, how do we really do the math? Now, if you're really interested in it after the lesson, if you want to kind of comb through your book in this lesson, they're going to show you some nice pictures, but I want to show you some nice ways. So let's start here. Write it down. How many 1/8 are in 1/2? And again, when this is sometimes you hear me talk about modeling. Sometimes when the numbers they give us are a little bit unfamiliar, maybe they're decimals, maybe they're fractions, maybe they're mixed numbers, our brain just kind of falls out the window because we're like, how do I do it? Well, one thing is I always suggest you can model. So if I was going to model a similar question like this, how many 2s are in 10? And I legitimately asked you that question, imagine everyone in the room is going to be able to tell me, well, clearly that would be 5, right? There are 5 2s in 10. So if you think about how could I have arrived at the 5 by using these values, 2 and 10? Well, there's only one way, and that would be for me to form this division problem. 10 divided by 2 equals 5. So again, if I use that as a model, then I realize that the first question, how many 1/8 are in 1/2, is clearly a division question. And I also want you to notice the backwards nature of it. So notice how they say 1/8 first and 1/2 second. Well, in our blue example, it says the 2's first and the 10 second. Yet the 10 is the first thing that comes in our division problem. So we want to mirror that. This 1/2 connects to the 10, so that would be the first thing to come, 1/2. Then clearly it's division. Then the 2 would come, or in this case, the 1/8. And I can form this question, 1/8 divided by, well, I'm sorry, 1/2 divided by 1/8. Now again, could we draw pictures? We could, and again, if after the lesson you want to look at some pictures, your book has some good ones for it. However, I want to move you quickly to, well, how do we deal with this? We have to introduce a term, though, that I don't think we've spent a lot of time talking about. And that term is involved in this Pavlovian statement. Division is multiplication of the reciprocal. And there is not a truer statement that we'll probably say all year. Now, if I just stopped after the first 3 words, division is multiplication, they might come and cart me off, because that's not true. However, if I say that division is multiplication of the reciprocal, I have pinpointed what division truly is. It is a type of multiplication in which we multiply what's called the reciprocal. Now you might be going, well, what's the reciprocal? I know, that's kind of a big idea. And we have to spend some time talking about this reciprocal. So let's go there now. Reciprocals. Now there is a good definition that I want you to remember, and it's this. 2 values whose product is 1. When we talk about values, we're just talking about numbers, any kind of numbers, but whole numbers, but also fractional, decimals, things like that. Now, if it says whose product is 1, we know that that should make us think of multiplication. So think about this for a second. I want to see if you can get this. So 2/3 times, who knows, right, is equal to 1. So again, obviously 2/3 is a value. What value could I multiply 2/3 by and get 1? You think about that for a moment? Yeah? Okay, well, I'm not sure if you are thinking about this, but you can. And the correct answer would be 3/2. Because you notice, even if we just multiplied straight across without cross-canceling, we'd get 6/6, which we know is equal to 1. But with a bunch of cross-canceling, everything's going to turn into 1s. Let's try another one. How about this one? 5/7. So if I multiply 5/7 by something to get 1, what would that something be? What would go in that box? If you think about the first example, then maybe you're concluding, well, wouldn't it have to be 7/5? And it sure would. That would be the reciprocal. So again, we say that 2/3 and 3/2 are reciprocals. Why? Well, because their product is 1. Or we say 5/7 and 7/5 are reciprocals. Why? Well, because their product is 1. Sometimes people just think, well, it's like the flipped form of the fraction. And that's true. However, I always want you to be connected to this definition as well. Let's look at another one, maybe a little bit more challenging. What about 1/3? If I was to multiply 1/3 by something and get 1, can you think about what that would be? Well, maybe you're thinking of 3. And then we could put it as 3/1, the flipped version, but really, ultimately, that's just 3, because that would equal 1, right? So 1/3 and 3 are reciprocals. Last example before we get back into our original problem. What about 9? 9 times what would give me 1? Hopefully you've seen enough examples and you're using your brain, and you would say, without a shadow of a doubt, that would have to be 1/9. Excuse me. And you'd be right, because I could place this 9/1 and then multiply straight across or do some cross canceling. And there I would get 1. So let's get back into our original problem that we were looking at. We've got 1/2 divided by 1/8. Now, something that's going to help us with the division is multiplication of the reciprocal, is a little mnemonic that I always want you to remember. It's 3 simple words, and it's this: stay, change, flip. And I remember being taught that in like 3rd grade. I don't know why they were teaching me in 3rd grade, but Sister Rosetta. Yeah, I think Sister Rosetta taught me that. It stayed with me all this time. And those 3 simple words help us, because the stay means that this 1/2, it's just going to stay as 1/2. The change, remember, division is multiplication of the reciprocal. The division refers to that I'm going to change that to multiplication. And then the flip refers to the reciprocal. So I'm going to turn this into 8/1. Now, as we know, when we multiply fractions, we always want to look for cross-canceling opportunities. GCF is the key to cross-cancellation. So if I focus in on that 2 and the 8, I think, what is their GCF? I'd have to say 2. So I'll divide each of them by 2. The 2 divided by 2 would be simply 1. The 8 divided by 2 would be 4. And then I could multiply straight across. 1 times 4 is 4. And 1 times 1 is 1, which is 4/1, which is just 4. I'll show that in the next time. Yeah? Kind of cool idea, huh? Let's try another. 3/4 divided by 1/4. Now, if we remember that division is multiplication of the reciprocal, and we're going to operate under these 3 simple words, stay, change, flip, then that means this 3/4 is just going to stay. The change refers to making it a multiplication problem. And then the flip means the reciprocal. So I'll place 4/1. Got some nice cross-canceling opportunities there. Obviously, the GCF of 4 and 4 is 4. So if I divide those both by 4, I'll get 1/1, which is technically 3/1. But that's not a good end answer, because 3/1 simplifies to simply 3. Boom. Box it. Yeah. We got another. This is fun. Ooh, 1 divided by 1/3. Now, if you think about that visually, it's probably a no-brainer. If you're going to take a whole circle and divide that into thirds, how many of those thirds would you have? But let's show it through our stay, change, flip model. So obviously the stay means the one's going to stay. The change means I'm going to turn it into a multiplication problem. And the flip means I'm going to put it 3 over 1. Now I can place this 1 over 1 over if it helps me. And then I multiply straight across. 1 times 3 is 3. 3 over 1. Well, again, we're not going to leave that as an end answer. We want 3. Boom. Yeah? And that, my friends, is the long and short of it. Kind of a new idea. I don't think you had experience, but I am interested in talking to you in our next check-in to see if this is something completely new. So we are going to, this was lesson 79, so you're to do homework 79. Hope you're doing well. Thanks so much for coming into the video and taking the test. I'll wait for your test to be given to me. I know that some of you already have. Thank you. Take care. Bye.